distinguished series of leaders in the space program who have addressed this community before. They're listed on the back of the blue program, which I hope you all picked up in the past. And that list is going to be added to by an equally distinguished member of our community, an old friend who has what arguably is the best job in Washington, at least the best job in Washington for a scientist. The Honorable Hans Mark is currently the Director of Defense Research and Engineering in the Department of Defense, which means that he gets to spend enormous amounts of money doing anything he likes, as I understand his job description, as long as it has to do with appropriate innovative work in science and engineering. This is coming back home for Hans Mark, who was a graduate student in physics here back in the early 50s, and he told me that he's going to be meeting with a number of his contemporaries for a reunion dinner tonight. He was working on neutron physics back in the days when the Van de Graaff generators were over in East Campus, over where the East Garage is, and the construction's going on now. He served after his graduate degree as acting head of the neutron physics group here at MIT in 1954. Went out to Lawrence Livermore Lab for a bit, came back to MIT where he served as on the faculty as an assistant professor of physics 1958 and 59 until finally the pull of Edward Teller, and those of you who've met Dr. Teller understand how strong that pull can be, pulled Dr. Mark back to California to the Lawrence Livermore Laboratories where he continued a very distinguished career leading to his appointment for nearly a decade on the faculty in nuclear engineering at Berkeley. I crossed paths with Dr. Mark many times. Each time I found it to be fascinating. I found him to be a man who had a wide range of interests. First in my experience was when I was doing flight simulator research at NASA Ames Research Center, and Dr. Mark was the director of NASA Ames Research Center, covering a whole range of topics from what would now be called astrobiology to planetary physics, and was responsible for the innovation of several of the earliest satellites for scientific exploration of the solar system. After leaving NASA Ames in 1977 and going to Washington, I found I bumped into him again when I was on the scientific advisory board under Professor Covert, and there was Dr. Mark as Undersecretary of Defense, and was trying to relate the virtues, as I told him today, the virtues of long-term R&D programs by referring us back to the virtues of Isaac Newton having supported the long-term development of the chronograph. Dr. Mark has had more than his share of time leading us in academia. He is a professor of aerospace engineering and engineering mechanics at the University of Texas at Austin, and at the University of Texas, he was their chancellor of the Texas system from 1985 to 1992. Dr. Mark is a welcome addition to those in the space community who have had the opportunity to visit us here at MIT. He's going to talk today about something that he wasn't allowed to talk about for many years. And when he gave me a choice of topics, I said, this is the one that we want to hear about, because it was off in the black world for so long. Dr. Mark will talk to us about space operations during the Cold War. Hans Mark.
Okay, is that excellent? Okay. See, I still know how to do gadgets here. I have to apologize because in the Pentagon, would you believe we're frugal? The biography they sent up was a duplex on two sides, Xeroxed on two sides, and they only got the first side. And that's why the blue thing doesn't mention MIT, so I apologize. I really was here. I remember a lot of people here who haven't changed a bit. And it's great to see all the new faces, so it's a pleasure to be here, Larry. Thank you so much for the invitation. I do want to talk about something that up until 1994 was classified. And what I am permitted to say is really only, hey, why don't you come on down? There are more seats. Don't be bashful. Just step over feet. And if you want to walk around here, and there you go. It was classified up until 1994, and the very existence of the organization that conceived, developed, built, and actually operated the satellites was classified. So all of the whole thing was supposed to be carried out under this umbrella. I'll get into the reasons for that soon, but what really was interesting, of course, is that the classification was really part of a fairly carefully, I don't know, in the Pentagon they always make up these slides, so I'm sorry. Yeah, you need to know that Sheila Widnall is one of my successors as Secretary of the Air Force. But, Sheila, I have to claim public credit for getting you interested in the Air Force, because I was the one who got you on the Board of Visitors of the Air Force Academy. So that was back in, what, 1979 or so, 78, somewhere like that. You haven't changed a bit. You still look great. Let me start by just talking a little bit about reconnaissance in general. Aerial reconnaissance has a long history because people used balloons for aerial reconnaissance 200 years ago. And in the United States, in the Civil War, that was the first time it was really developed consciously. And the first aerial photograph, actually, was a picture taken from a balloon here in Boston. It's a picture of downtown Boston with Beacon Hill and the Capitol and all that. And it's a very nice high-resolution picture because it was taken basically by a pinhole camera. So you had, I don't know what the NIRS rating would be, Sheila, but I'll show it to you sometime. NIRS rating is an in-house term for resolution. And so on and so forth. The airplanes were used for reconnaissance, of course, in combat. And in World War II, of course, aerial reconnaissance came into its own. It was widely used, and it was decisive in many instances. For example, the Bismarck was spotted by a PBY, consolidate. I can't remember what was the name for those things, the twin-engine ones. You almost had it. I'll remember it in a minute. And of course, in the Battle of Midway, those same airplanes also were the decisive element in spotting the Japanese fleet. The P-38 was also they had a reconnaissance version that was called F-5A. And the reason I mention that at all, it was designed by Kelly Johnson, who later designed the U-2. And Johnson was very interested in reconnaissance from the word go. And the aerial cameras, interestingly enough, were developed by people here from MIT, later iTech and other companies that spun off from MIT. So there is a long history of involvement here at MIT in aerial reconnaissance. And of course, the related field of photo interpretation also became highly valued. And Constance Babington Smith, who was a Royal Air Force officer in World War II, was the person who identified the V-2 rockets at Peenemünde for the first time. And come on in, sit down. Yeah, I hate to, I hate to see people stand up. All right. Anyway, she was the one who identified those pictures for the first time and alerted everybody to the fact that there was something new coming on. Now, after the end of the Second World War, aerial reconnaissance, of course, is that, I don't think that's quite focused. How do we? No, that's good enough. That's better now. Yeah. Okay. All right. Really, the principal reason for reconnaissance was the Soviet nuclear testing. At that time, the Soviet Union was closed, and one had to figure out how to look at their nuclear test sites to find out what they were doing. And the first Soviet nuclear explosion was in 1949 in September, and the debris from that explosion, the radioactive debris, were picked up by an RB-29, a reconnaissance version of the 29. And the first hydrogen bomb was about 4 years later in August 1953. So there was a reason for doing aerial reconnaissance, and I've already mentioned Kelly Johnson. What was done, of course, was to develop a high-altitude aircraft, the U-2. Kelly Johnson designed that airplane, and the important point is this one here, that both the aerial reconnaissance, the advanced airplanes, and the satellites I'm going to talk about were developed because of a committee that was headed by Jim Killian, who was at that time the president of MIT, and Edwin Land, who was at that time the head of the Polaroid Corporation. I found out, much to my pleasure, that the author of this biography of Edwin Land is in our audience here, Dr. McElhenney. And I haven't seen, this must be the first biography of Land, is that right? Yeah, this is the first biography of Edwin Land. He was an absolutely remarkable person, had a very strong connection with MIT. I think was an institute professor after a while, wasn't he? I believe that after he quit Polaroid, he came over here to teach. I worked with him briefly when I was a graduate student here. Interestingly enough, the project I was on was that he was asked by the American Institute of Physics to give, they used to have these lectures on the various topics in physics, and he was asked to give the lecture on optics, and he hired me to help him write that lecture. So I learned almost all I knew about optics from Edwin Land. A very, very remarkable guy. This committee was set up in 1954. It was actually chartered by President Truman and President Eisenhower. The charge to the committee was, how do we do reconnaissance over denied territory, over the then Soviet Union? And the committee did something that was very interesting. They said, let's build this airplane, the U-2. And the project for the U-2 was initiated in November '54. The first flight was in July '55, and the first operational mission was in July 1956. I wish I could say that we could do things like this as rapidly now as we used to do them then. The remarkable thing about this committee was that they said airplanes get shot down. At some point or other, the Soviets will learn how to shoot down the U-2, and we better have something in our back pocket when that happens. Not if it happens, but when. And so they also initiated at the same time a program of Earth-orbiting satellites as the ultimate solution to the reconnaissance business. And that, of course, is the main topic of my talk. You do remember that the U-2 was shot down in May 1960. And what is remarkable is that the first reconnaissance satellite was launched a couple of months later. Yeah, come on in and sit down. We got plenty of room. All you have to do is step on a few toes, but other than that. Now, satellites, Earth orbiting satellites were, the subject of science fiction for a long time. But the first really serious calculation of what you'd have to do to get an Earth orbiting satellite into orbit and do something useful with it was made in 1946 by a group at what was then the Douglas Aircraft Corporation and then spun off to be the RAND Corporation. And that was called the Preliminary Design of an Experimental World-Circling Spaceship. And in that report, one of the major reasons for doing this was to say if you put a camera on this thing and look at the Earth, you can do military reconnaissance. So that was from the very beginning in 1946 something to do. I've already said that the program was initiated in 1955, and there were really two distinct programs that were recommended by the Killian-Land Committee. The one was essentially a program that was supposed to observe missiles that were being launched, and the other one was a program to take high-resolution pictures to judge what technical capabilities the Soviets were developing. As I've already mentioned, the U-2 was shot down in May of 1960, and in October, the first Samos satellite was launched. The first photographic satellite was launched. So the Killian-Land Committee, the parallel recommendation that we do high-altitude airplanes and satellites at the same time, turned out to be a very important thing. That launch was a failure, but the first successful flight was carried out in 1961. The code name for this thing was Corona. More than 100 Corona missions were flown. I think it was, in fact, 152, if I remember correctly. The program was terminated in 1972 and has been declassified since 1994. And I'm going to talk about that in some detail. And then I can talk about other things that we've done, because some of the other things have been declassified, but they will be stories rather than detailed data. This is one final word chart. There was a debate as to how to run this satellite program. And there were really three considerations, and that's the first bullet up there. First of all, the customer was the president. So that the word national and National Reconnaissance Office means that it was set up to serve the president's requirements to know what was going on. Both civilian and military people would be involved, because there was a mix of civilians and military who had capabilities in this business. And that meant that you couldn't give it simply to a military service. You had to kind of mix it up and create something new. And the last point is that secrecy must be preserved. And that secrecy really had two separate reasons. The first was that you are gathering intelligence, and you don't want the gatherees, the people you're gathering on, to know how good you are or how bad you are or what you know or what you don't know. And so there was technical secrecy. But there was an even more important reason for secrecy. By this time, Khrushchev was in office. There were still, problems, but it was really the era of the thaw. You remember there were the summit meetings began. The coldest part of the Cold War was really kind of over. And the Russians let us know that okay, we know you're going to do these satellites, but we'd rather not that you talk about it. It would be harmful to our own position in the Soviet Union, and we'd like you to keep this very secret. And so we said, yeah, we're going to keep it secret anyhow. And so secrecy, therefore, was agreed upon tacitly by both sides. It was also a kind of secrecy where there were, over the years, calculated leaks. Because as I will tell you shortly, one of the very important things that we did with these satellites was to do the monitoring of arms control treaties. And consequently, it was important for people to know, in quotes, that we could indeed monitor them without telling people overtly that we were doing it, and certainly without giving away the capabilities of the systems. And so there was kind of an interesting situation where, when I was serving as director of the National Reconnaissance Office in the late 1970s, where a newspaper man would call you up and would say, you know, what's going on with monitoring such and such? And I would say, what are you talking about? And, well, we know you're head of the NRO. I said, what's that? And so we had this rather strange situation where people would know, and then we would have to say a few things, and finally we'd kind of wink and you know, say something that somebody in the White House or in the State Department had decided that, yeah, we ought to let people know that we can detect such and such or this and that. So it was a secret organization that had an important public function. And the public function, of course, was to create confidence in the public that we could indeed enter into these treaties in such a way that we could know that they were being honored. Anyway, the solution to all of this was a single organization, the National Reconnaissance Office, and it was to conceive, develop, build, and operate satellites. It did all the four things. That's a unique thing. The director of the NRO was a senior member of the intelligence community, and the undersecretary's position in the Air Force was the cover name for that. So in my biography it says I was undersecretary of the Air Force. What I was really doing is this. Now, there's another interesting thing about the NRO, because the head of the NRO is the only other civilian in the Pentagon who actually has command authority over the military. See, the Secretary of Defense has command authority through the chain to the President and then to the Chairman of the Joint Chiefs and so on. The head of the NRO commands a military organization. The ground stations, the various facilities necessary to run the satellite systems are manned by the Air Force and sometimes by the Navy. So there are military organizations, and these organizations actually take direct orders from the NRO staff. So the NRO is, in a very real operational sense, a military organization. It is interesting that when I was director, it's now become, of course, now that it's declassified, it's much larger, for one thing. A lot of other things were incorporated. They have a fine building now in Chantilly, Virginia, if you ever go. I was absolutely blown away when I saw this thing with the NRO letters on it, which were totally secret in my day. We were hiding in a small office suite in the Pentagon in the C ring, which is, you know, way below the salt, so to speak. But now it's a fancy office. But it's also different. It's changed, and it has, in addition to the responsibilities it used to have, which were primarily peacetime reconnaissance, it now also has a large job of supporting military operations. And so it's really a very different kind of thing today than it was in the years that I headed it. And I was director from early 1977 to late 79, about 2.5 years. And that was sort of the height of the mission where our primary mission was arms control, because you'll remember that in the Carter administration, Assault 2 was coming on, and the president's major function was to or major objective was to push that through. And in order to do that, we had to demonstrate that we could actually monitor the treaty. The office was chartered in 1960, and Joe Cherick was the first director. Now let me talk about physics and engineering for a while, enough of the politics. The first photographic reconnaissance satellite that was really an operational vehicle is this one here. This is the Corona satellite. KH-4 was the code word for it. And this thing was a rather large thing. This is, it was about, let's see if I can work this thing, good. This was about maybe 15 feet by 7 feet, so it's a big thing. And it was a photographic camera. This is the film roll, and here are the two cameras. There were two cameras, two panning cameras, and I'll show you a diagram of this thing shortly. And the film was exposed in a cassette up here, and the camera rotated. And as the camera, the lens rotated past the ground here, it would put the image on this, it would scan the image on this film, and when the camera wasn't looking at the ground, the film would advance, and then it would take the next one. And you had two cameras, and you rotated them in opposite directions so that the moment of inertia is canceled out, and so you had a spacecraft that you could easily control. It was a pretty clever design. There were also up front here what we called the buckets, and these were the take-up spools for the film. There were two buckets on this thing. This is the first one, and here's a second one here. And these have heat shields on them, and these were recovered. We would drop these off and recover them. And the way this thing worked is that it was recovered close to Hawaii. We had a squadron of airplanes here. I'll show you a picture of one shortly. And we had rigged up a way of snagging the things coming in on the parachutes, and then we would haul them. We did this several hundred times, and in that period, only 2 buckets were lost, which was kind of a pretty good record. Let me show you some more details on this thing. By the way, the KH-4 is, you can see this in the Air and Space Museum. This is a kind of a blown up model of the KH-4. Here are the two, this is one camera and here's the other one. And the spool is here, and then here's the first bucket and the second one was here, and they took the shield off so they could show how the take-up spool worked. And this is about the size of it. I don't know where they have it now. When I took this, I actually took this picture. They had it right after they put the exhibit up. They had it next to the escalators there in the museum. Here's a top view of this thing. Again, you can see the general structure of this thing. This film, I think, was, what, 125 millimeters, something like that. I can't quite remember it, but it's a pretty it's a big film. And of course, you had a very good, the telescope, the optical system had a 15 centimeter lens on it. Let me show you a line drawing so that you can get a little more details on that, and then we'll get to showing you how the geometry actually worked. This is the line drawing, so that here's the film spool, here are the two cameras, here are the two buckets. And then there were other things. Of course, you had to stabilize this thing in space. So you had to have star sensors to keep it locked onto a star. And it had to be stabilized very carefully, because if you want high resolution, you don't want the camera to vibrate. So that was one of the important technical problems here, was to develop a guidance system that gave you really a good 3-axis stabilization so that you could take these pictures. And you had to have, of course, 3 references, and one was a star, there was a horizon sensor, and I don't quite remember how the rest of it worked, but I'll have some pictures of it later on so you can, yeah, here, in fact, here it is. Here is kind of a line drawing of how this thing worked. The satellite, this is kind of a cutaway that shows only the cameras, and then the star sensor. There's an index camera to number the film, and there is a horizon camera here, which stabilizes the thing against the horizon. These were nearly circular orbits, and they were low orbits of the order of 100 miles, 100 nautical miles or so. Now, and I've already said the cameras rotate around, and as they rotate, they pan across these things on the ground here. This is about 150 nautical miles by 150 nautical miles. And the cameras, as I already said, are counter-rotating. And of course, when you do this, you get stereoscopic images. That's one of the things that was really important about this thing, that we could get good stereo images. But this is kind of the way the thing worked. And of course, as it flew in orbit around the world, it covered a lot of territory. Let me show you the territory covered in a sample mission. This is in one mission. These were the pictures that were taken. Missions used to last a few days, maybe a week or 2 before you brought the buckets back. You can sort of see that the target was the evil empire at the time. And these were chosen for various reasons, missile fields or industrial centers or something. Middle East was of interest then, and so was, I think this may have been at a time when India and China were having problems, so this was taken here. China is a target. Korea, of course, was and still is a target. But this, a sample mission would run something like 3 million square miles. So you got, say, 1 United States in each mission. Got it? Okay. Now, I promised to show you how the things were picked up. This was an old Fairchild C-19, and this had a back door. We finally used 130s for this rather than these airplanes. But you'll notice there was this rig out here, and this loop here caught the parachute. Here's the bucket, there's the parachute, and you'd fly along and watch the parachute come down, and the pilot would fly over it and catch it and pick it up. I went out on one of these missions, and it was kind of fun. These were U.S. Air Force airplanes, and we had sometimes we had a helicopter. When the thing was close enough to Hawaii, we had a helicopter down there to fish it out of the water if we missed it. But that was the way these buckets were picked up. From the Corona system, you'd have your data back within a couple of weeks. So it wasn't totally real time, but it was pretty good. This is the first satellite photograph from a Samos mission of an airfield in eastern Russia taken on August 18th, 1960. And here you can see the runway and the tarmac, the flight line. The resolution wasn't very good because we hadn't learned really how to tweak this thing yet. But that is kind of historical because that's the first one. And again, let me repeat, the remarkable thing is that it was taken a few months after the U-2 was shot down. And you know, for Killian-Land and Killian and those people to sit down and say, hey, the airplanes are going to get shot down, we better start on satellites, and then to arrange the program so that the satellites were ready when the airplane got shot down was really something, something quite unique, I thought. Now, I told you that the real reason for this was the counting of the strategic weapons. And this is a typical picture that was taken in 1962 of a ICBM site here, and the support areas and all these things. People always ask me, you know, did the Soviets do the same thing to us? The answer is they had reconnaissance satellites, but they really didn't need them because you can drive around the United States and see these things out west, and the locations are public knowledge, so it's no big deal. Anyway, this is a missile site. Early on, very early on, in the early 60s, it became apparent that one of the things that the NRO could do and did was to help with various disasters. Now, this was not a disaster. This was a volcanic eruption on the Kamchatka Peninsula, and you can see the sun was over here. Let's see, I always get confused here. This is the lava flow. This is the shadow of the cone, of the volcanic cone here. And then there is a steam vent over here. The main point is that you could very quickly analyze what was going wrong in a volcanic explosion. I remember during my term as director, there was a major eruption of a volcano in South America, in Colombia. And there was a real disaster with what happened was that this mountain had snow on it. And of course, when the top blows off, the snow turns into water. That turns into mud, and it goes down the side of the mountain and sweeps everything out in its way. We were able to spot with our satellites isolated people that had to be rescued. And of course, once we had the satellite pictures, we deployed U-2s. And these reconnaissance capabilities have been used for disaster mitigation all along. I remember we also had an earthquake in Mexico City that we monitored and looked at. We actually declassified some of the pictures, even under when I was director. And what we did was we fuzzied the resolution so that we could declassify them, and then just gave them to the rescue people who had to do the job. Of course, China became a target when they became a nuclear power. This is the first Chinese nuclear test in 1964. This is the crater here. The Chinese test site always had these circular exclusion zones. I don't know how they drew these circles on the ground, but it's kind of remarkable that they really had this unique thing that before they'd run an explosion somewhere, they'd have a circular. You see this one here? They had these circular exclusion zones. But that's 1964 at Lop Nur. This is in western China. Here is a typical picture that was taken during the mid-60s for reasons of arms control. This is a Soviet strategic air base, and this is a long runway. And here you can see. You can't see them very well. This is I should have enlarged the flight line here. But there are about 50 heavy bombers These are a mixture of the Badgers and the backfires that they had at the time. I'm sorry, that's too early for the backfire. These are Badgers and 97s, Tu-97s. And they were on this line here, and there were about 50 of them. And of course, in the arms control negotiations, the question of how you count these things was important. And really, the early satellites were terribly important in giving people confidence that you could do that, you could do the counting. One of the things that happened to me when I was director is that I've already mentioned that President Carter wanted to do SALT II. We had an arrangement with the Congress when I became director in 1977 that the National Reconnaissance Office would get $1 billion a year, no questions asked. There were only 2 people in the Congress who were cleared at the time. And they were the 2 heads of the intelligence committees. Not even the Armed Services Committee people were cleared. And there were no staffers cleared. And the budget was hidden in the Air Force budget. And the Air Force budget is big enough so that $1 billion here and there didn't attract too much attention. But what happened in 1977 was that SALT II was a treaty that was quite sophisticated in the things that had to be monitored. And I remember Spurgeon Keeney, who was at that time the deputy director of the Arms Control Agency, came to me and said, what can we do with the systems we have? Because we had better write a treaty that's consistent with what we can monitor. And in our talk, we came to the conclusion that we really couldn't write a treaty beyond SALT I that would be reachable by the current system that we had. And so we decided that we would go to President Carter and say, look, if you're going to do the SALT II, then we need more satellite systems. And I remember the Keeney, his boss was Paul Warnke. We went to see the president, and Carter said, well, how much do you think it'll cost? And so horseback guess was another $1 billion. Turned out to be 2, by the way. When I left the NRO, we had a budget of $3 billion. And the president said, okay, go do it. But then he said, we're not going to get this through the Congress. And so 1978 was the first year when we had to go and clear a lot of people in the Congress, because in order to break that $1 billion barrier, we really had to go and tell more people about it. And so really for the first time, the NRO had to establish the normal kind of relationships with the Congress. What that meant was that we had to make some pictures that people would see. I'm showing you one that looks like one of those pictures. I can't show you the real one because it's still classified. But what we did was we took pictures of things around Washington. This is the Washington Monument here. And the reason I had a very good resolution picture of this thing here's see, I've got to get myself oriented here. This must be the bridge. Yeah, this is the 14th Street Bridge, and this is, I think, the Agriculture Department, and it goes down this way. But anyway, this is the Washington Monument, and of course the important point is that sometimes you want to know how tall a missile was, and you do that by looking at the shadow and the sun angle. And I remember we had a picture like this for the people in the Congress where we could say, hey fellas, we can tell how big these things are. And of course, once we started doing that, I remember going around the halls of the Congress with these pictures, showing them to the people who had recently been cleared. And of course, one thing we always did was to take a picture of the Pentagon. And those of you who have lived in the Pentagon will know that there's a hamburger joint down here which is called Ground Zero. So, and in the summertime we go have lunch there. Now, one of the very interesting things that came out of the later missions, and I'm showing you now a picture that was taken with infrared film, was the assessment of Soviet agriculture. You remember that the Russians a number of times, the Soviets a number of times cornered the grain market. And we wanted to prevent that. And to do that, we had to estimate what their yield would be. And the way that was done was to fly these things with infrared film. And then it turns out, unfortunately, I don't have a color picture of this. It turns out that the individual crops have rather unique signatures. So that if you, say, have a 3-filter camera, you can kind of tell whether you're looking at wheat or corn or vegetables or things of that kind. And this is an example of Lompoc, California, where there's a lot of truck farming around here. And we did this systematically with the Soviet Union and predicted the yields better than they could. And eventually, of course, we told them that. And they said, well, why did you tell us what you're learning? And it is now, of course, this, as you know, is a commercial thing now. You can buy these pictures, and people who are in the agricultural business do so. Here's another interesting picture. This, by the way, is one of the best pictures that was taken by the Corona system. This is the shipyard in Severodvinsk, which is up on the White Sea. They built their submarines in this building. This is a huge building here. And then these were basins that they'd fill up when they launched the submarine. This was taken in February, so this whole harbor is frozen over. In fact, you can see tracks of vehicles here that they ran on the snow, on the ice rather. The resolution of this thing is about a 1.5 feet. Here are the docks. Here's a submarine, and these were the docks where the finished ships where the nuclear fuel was installed here in this area. I remember one amusing incident was that we had a problem that we had somehow miscounted the number of submarines the Russians had. They had more than we thought they had, and that was rather a mystery for a while until we saw a submarine here at this dock, and it looked like a black missile sub. And then that night there was a storm, and when the next picture was taken, the submarine was bent into a 90-degree angle, and the mystery was solved because they had made some dummy submarines basically out of rubber, I guess, and had parked them in with the other submarines. And it wasn't until we saw this one that was destroyed in the storm that we realized what they had done. So there was a certain amount of kind of cops and robbers that went with this thing. There's another reason why this picture is clear, by the way, because at northern latitudes, when there's no wind, the air becomes very, very transparent and very, very still. All the junk is condensed out, and it gets cold up there. So you really have a very clear view. Here is another interesting picture. I showed you the pictures of Washington, and of course we have to also show you pictures of Moscow. This is the Moscow River here, and here's the Kremlin. And here's an enlargement of the Kremlin. And what was interesting about this picture is that this was 1970. Here are the people lined up to go into Lenin's tomb. See the line of people? So eventually we got to the point where we could actually see individual people on the ground. I remember, the only time, Sheila, that I ever got called by a president was by President Carter. He called usually for two reasons. One was when we didn't give him the pictures that morning. and he wanted to know what the hell happened. And he was an engineer, so he wasn't satisfied with just it isn't working. He wanted to know why. The other time he would call was for serious things. This business of looking at people was important once when the Chinese invaded North Vietnam in 1979, or 78, I think it was. And the Russians, remember that North Vietnam was really a satellite of Russia, and China was rather ambivalent about this whole business of the war there and so on. And after the war was over, they invaded North Vietnam. And I remember the Russians threatened to invade China. And we got a call from the White House saying, is this credible? And so we targeted the border between Russia and China with our satellites. And I remember the first pictures that came back, I looked at them, and there were, troops out playing soccer and, doing things that it was crystal clear that they weren't mobilized. They weren't ready to go anywhere. And we showed those to the president. We said, look, the Russians are bluffing. That's the kind of value that the president put to satellite reconnaissance, because by doing this kind of thing, you could kind of gauge intentions, which was important. In that same incident, we also discovered something else that was interesting, and let me digress for a minute from these satellites and talk about other things that we do from space, which are still highly classified, but I can't talk about how well we do it, but I can tell you that we intercept messages in space. And we watched the Chinese invasion of North Vietnam and intercepted the chatter, the traffic, the radios, voice radios. And I remember listening to one tape where a guy commanding a tank column says, we're coming down this road, but the North Vietnamese have artillery on the hill over there, and they're going to shoot at us, and we're about out of gasoline, so I'm not going to go in there and then be a sitting duck. And so the colonel back says, you better go. And so then the captain in command of this tank platoon says, well, where's the gasoline? And so the colonel said, you'll get it soon. So we were kind of interested in this whole incident, and we targeted it with our photo satellite. And what we discovered was that these tanks were sitting in front of this artillery position. The captain did not, in fact, go until he got his gasoline. And he's got his gasoline by a mule train that came up with gasoline cans, jerry cans on either side. And that gave you an insight into the logistical capabilities of the Chinese army. I mean, they had modern tanks, they had modern comm gear, but the gasoline came up with mules. So these were the kind of incidents that. That's right. By then we had real-time imagery. We had electro-optical systems. So I just mentioned the fact that the breakthrough here was seeing individual people, and from then on we had systems that could kind of do that. We also did a lot of economic work. This was kind of interesting because gold is another thing where the Soviets had a lot. They had a lot to do with the gold market and so on, and we used to target their placer mining. You can see this kind of thing all over California. It's basically you fill up a basin here and you run a dredge in it, and then these are the remains of the placer mining. And this is a more accurate picture of the dredging operation here. But the interesting thing is that the side information we got here is that there was a logging area next to this, and they were clear-cutting this mountain. So we learned that they were sure as hell digging gold, and that their logging techniques were essentially to clear-cut large areas. Now they have a lot of forests, many more than we have, but these were the kind of things that were pretty common, and these were sort of accidental targeting rather than deliberate ones. Let me just run through these very quickly. This is an IRBM complex. This was very controversial because people worried about ranges of rockets and should they be in the treaty or out of the treaty and so on. So we did a lot of work on that. This was 71. This was almost before this. Remember, this program was shut down in 72. So by this time, we already had better satellites. We also made some very interesting archaeological discoveries, sort of pretty much by accident. This is remains of a Roman fort in Jordan. And this was, this is underground, by the way. This was, you can't see it from the ground, but you can see, here's some modern buildings. But it was really located first by this satellite picture. And probably the most interesting environmental things that we've done have to do with the fact that the corona system started in 1960. And so we have 12 years of history that we didn't know about until this thing was declassified in 1992, 94 rather. And you remember the stories about the Aral Sea were published for the first time in that year, and the reason was that we had pictures of the Aral Sea as it was before the real problems began. Because what happened was that the Russians encouraged mass emigrations to the regions to the south of the Aral Sea, where the river, see there's a mountain range down here in the south, it's part of the Himalayas actually, and the runoff from those mountains fed the Aral Sea. And what they did was they encouraged agriculture in this area down here that came from rivers, that was irrigated by rivers that came from these mountains here. And so the Aral Sea didn't get any water, and it evaporated. And you can see this picture here was taken in 1962, and this was 1994, 32 years later. And so these extra 12 years gave us a real picture of what happened there. And of course, this is only one example. There are numerous examples of this where we actually could extend the period that we were where we were monitoring various environmental things. Let me wind up now just with one other slide here. And this is kind of a summary of the achievements of the system. I mentioned this one here, and I really think this is the most important thing. I don't think we'd have any arms control treaties if it weren't for the satellites we had. Technical capabilities. I should let me tell you another story that was interesting. I ran an aeronautical laboratory for a while in the 1970s, and how many of you in this room have heard of something called the Caspian Sea monster? There are a few of you. I better tell you the story of the Caspian Sea monster then. In the late 1960s, it was one of our attaches in Moscow. In those days, you got to Moscow by going through Tehran. You flew Pan American to Tehran, and then you flew Aeroflot up to Moscow. And this guy was flying on the Aeroflot airplane over the Caspian Sea. And there in the Caspian Sea, he saw, looking down, a huge airplane flying at low altitude. The thing had, I don't remember, Sheila, it had canards, I think, and 2 engines on the canards, and it had wings with 3 engines under each wing, and then it had a high tail with a couple of more engines on the tail. I mean, it was really bizarre. And I remember I was sitting at Ames at the time, and an Air Force colonel came by and with some pictures of this thing that had come out of the NRO, and he showed them to me, and he said, "Can you tell me what this is?" You know. So I said, "Well, if you can get me some better pictures, maybe we can make some wind tunnel models and actually test the thing in the wind tunnels and find out what how the thing works." And so we got some quite good satellite pictures of this thing in flight, in the water, on the ramp, and so on. They built about 4 of these, I would say. But they were 747-sized aircraft and probably heavier because they had more engines, and it was, they were kind of low-tech machines. And I remember reporting to what was then called the Foreign Intelligence Division at Wright Field. And I went there and I gave them the results, and I gave a little talk about it, and I said, whatever it is, it doesn't fly very well. It's just not a good airplane. And that it would only work in ground effect. That is, it would really only work at low, you know, if maybe 50 feet above the ground, but not better. And so, you know, the mystery was what were they going to do with this thing? And so for years, the Caspian Sea monster was always on the top of the agenda of all these intelligence committees and so on. And I finally, when I became Secretary of the Air Force, one of the things that happened was that the Foreign Intelligence Division came by, and they, sure enough, on the top of the agenda was the Caspian Sea monster. So I said, "You mean you're really still worrying about this thing?" And they said, "Well, yeah, but we got to figure out what it is." I said, "I'll tell you what it is. It's a screw up." You know, they didn't know what they were doing, and then I said, it is the nature of the Soviet Union that it is highly probable that the vice admiral who runs this program is married to a cousin of a member of the Politburo, and they don't know how to shut him down. You see? So this was several times we had things like this, and seriously, one of the characteristic things about the Soviet Union, and probably one of the things that drove them under eventually, was that they do not have the review system we have here, the adversary system. And so what that means is that they'll start a program, and we had a number of facilities like this that were truly mysterious because we really couldn't say, well, they don't quite know what they're doing, because maybe they knew more than we did. So we always had to be a little careful. But they don't have both the classified and the unclassified adversarial system we have here, where, you know, the public discussion over whether some weapon system is useful or whether it works and so on is one of the most valuable things we have in this country, because it's a filter, and it really prevents us from doing a lot of nonsense. And I think that's one of the important lessons out of this thing. I ought to talk about the South African nuclear test program. That was also interesting. That also happened on my watch. I remember we got a call from somebody in the State Department, and the guy said, "Come on over, and I want to talk to you." So I went over, and he had a cable that came in from the Russians, which essentially said, there's something interesting going on at coordinates such and such and such and such in the Kalahari Desert. And the guy in the State Department said, "Can you do this?" And so I said, "Well, then," I said, "Yeah, sure, we can do it. We can target that. But why do you want to know?" "Well, the Russians think there's a nuclear test about to be made there." And so I said, "Well, all right, why don't you tell them?" Well, what happened was that we sent them a cable which said, "Nonsense, it isn't so. So we better find out whether it is or isn't. And so, all right, we targeted the satellites on this thing. And sure enough, you know, I'd been in the nuclear test business when I was at Livermore, and sure enough, this thing was, you know, it was a precise facility for an underground nuclear test. There's a hole in the ground, pad around it, then a few hundred feet away there was a blockhouse, just everything you'd have. And I went back to the guy in the State Department. I said, you know, you fellas should have done this before you told the Russians nonsense. This is a nuclear test site. And basically the reason the Russians gave us the information was that they wanted us to put pressure on the South Africans to stop it. And so, you know, the State Department cabled South Africa and said, knock it off. And then they called me back and they said, well, we told them to knock it off. Would you please check and see whether they actually did? So we continued to target this thing for the next few weeks, and they pulled that thing out of the ground. Toot sweet. I mean, it was gone in a week. The hole was filled in, the buildings were blown, and the trucks took everything away. They never ran a test on the continent. And, but they did build weapons, you know. They did learn how to separate uranium to do U-235. And so, again, we could tell that. Well, I think I've kind of covered all this stuff, and why don't I quit here, and I'll be happy to answer any questions if that's appropriate. It's all right, they can hear you. Here. Here.
Thank you very much,
Okay.
Dr. Mark.
Thank you.
It was outstanding.
Thank you.
Before pausing for questions, let me present you with our certificate of appreciation
Oh,
to
gee.
fill
Thank
in
you.
whatever empty spaces there may be on your wall in the Pentagon, and open.
I tell you, at my stage, the only things I have on my wall in the Pentagon are pictures of my grandchildren, okay?
Sounds like a good stage. Questions?
Sheila.
At what point did you move from the drop film to the direct?
78.
I mean, that was part of the Corona program? You did
No.
that in the Corona
No.
program? Oh, the Corona was
Corona was shut down in
dropped.
72. We had several other film systems that are still classified. And we did the first real time in 78. And again, that was when I was director of the NRO, and that was kind of a really interesting thing. Yeah.
Say something about the retrieval system.
Would you wait for the mic, Walt, and repeat your question? Okay. Because we are taping.
Oh, okay. Could you say something about the retrieval system? I thought you said it once that they dropped a couple.
Yeah, there was they missed a couple, and I think one of them just sank. And the other one on some recovery missions, we had helicopters flying under the recovery airplanes. And so one of them was picked up by a helicopter, one of the buckets.
Hans, this is Gene Colbert.
Where are
Your
you?
supposition is correct,
Can't see you.
except that it was Brezhnev's nephew that was running the...
Okay. Was it really?
I just thought you'd be curious.
You know, my supposition was a pure guess, and I didn't know who ran the program. I just said there's somebody who runs that program who has connections. So, no, is that really a fact, Gene?
That's a fact. I was told that...
I'll be goddamned. That's the first time I've heard about it.
Dow Smith, who actually developed the
Hi.
camera.
Well, I was involved in it. I have a question about the NRO, but I have to make a comment before, so that people understand my question. I have to make it clear. You had mentioned SAMOS.
Yes.
SAMOS was an Air Force program, which of course was distinct from Corona.
Right.
And that ran during the 1950s, and it was a combined ICBM, camera, do everything
Right.
Satellite program. It was going very slowly, and right after the Russian Sputnik in September of '57, Eisenhower became concerned about the speed of it, and his immediate advisors said we should look at the model of the U-2 program, which the CIA ran in a very streamlined fashion, and let's do a fill-in satellite program. So they started planning between, in December of 57 through the end of December 58, all the briefings at high level were totally verbal. Because of the sensitivity of the competition, they knew it was going to erupt. They went out for proposals in January of 1958. The proposals were in, the contractors were selected by the beginning of April. The program was funded by the middle of April. Specifications were begun a month later, and the specifications were set in concrete in June. A totally ridiculous, absolutely impossible project. Anyway, the program succeeded as you've described so eloquently. But after the NRO began in, I think,
1960.
Incidentally, I think there were 13 unsuccessful launches before the first one in August of 1960. Those were the so-called Discovery programs.
That's right.
Some of you may remember it.
Right.
Anyway, after the NRO got going, the CIA was very angry about it. They wanted to preserve their turf because they thought they'd done a good job. And during the first 5 years of the NRO, the infighting was absolutely fierce.
Oh, I have to tell you, it was fierce when I was there, and that was 12 years after the
You've answered my
start.
question before I've asked it. It's just been published.
Oh, yeah.
A declassified history of the NRO between 1960 and 1965, which goes blow by blow. It is absolutely fascinating.
It continued blow by blow.
But my question was, what was the NRO like in 1977?
Well, it was the same infighting.
And was this Air Force versus agency, or what was
Not
that?
basically, but look, it was very good because it, again, you know, it's interesting that competition in the private sector is admired. It makes for efficiency. Competition in the public sector is called duplication, okay? And we have to cut out duplication. Now, why people in the public sector are motivated by different things than people in the private sector, I don't understand. The fact that we had competition between different agencies in the NRO that participated in the NRO, between the military agencies and the civil agencies, actually made the agency as good as it was. There's no question about that in my mind. We would not have had the quality of the people like Bud Whelan, who was a contemporary of mine here in graduate school, in that program if it weren't for that competitive element. There's no question about it. And you know, competition leads to problems. And the director had to adjudicate between some very, very aggressive people, and that led to a few interesting discussions. Yeah.
This might be a little out of the scope of your talk, but could you say anything about the status of knowledge 1955 through 57 concerning the preparations in Russia? The state of their capabilities.
55 to
55 through 57.
in capabilities in the space.
In the military sense.
Well, no, I can't really. I mean, that's a tough question that requires a very long answer. I can't say much here.
I was wondering about the consequences of that first U-2 that was shut down. I mean, I know that people saw it was coming, but still, it's a U.S. airplane shut down by the Russians. So, like, did that have any political consequences, or just
well, remember that it was a little more than that. I mean, it was a U.S. airplane that we flew secretly and never publicly talked about, and it was even more amusing because it was flown by NASA undercover. What? No, I'm sorry. It was by NASA. Okay, NASA was the cover. And the thing that was interesting is that when NASA was called up and said, what's all this about your U-2? They said, what are you talking about? They didn't know they were the cover. So, but the answer to your question is that, that it was a covert flight. And so, and the Russians, of course, knew it because they could see him with radar and visually. And they finally developed a rocket that could shoot it down. That was the... yeah. Talking.
Hi, Scott Shannon. I just was wondering what you would say about the security issues involved with the availability of high-resolution reconnaissance now to anyone online, and also high-resolution GPS coordination.
Well, you know, that's also a very complicated question. The real issue is targeting. That is, how do you use a combination of the things that you talked about to target, to use as a targeting device for military operations. And the answer, of course, is that you can do it. Now, it's not easy. So I'm not sure that anybody except ourselves right now have the sustained capability to do that. But it's certainly there in the open, and we have to assume that a lot of other people are going to learn how to do this fairly quickly. I mean, we used it in Kosovo for sure, as you know. Lee Grodzens, how are you? Good to see you.
Hi.
I didn't notice you. If it weren't for that light, I would have seen you.
This is a technical question.
Sure.
Being a technical nerd, I have to ask you a technical question. And I've been brooding throughout your talk about this counter-rotating system of two cameras, and how the hell you do a stereoscopic vision with that.
Oh, you don't do it with the stereoscopic.
I mean, I can see the stereoscopic, but
I'm
two
sorry.
eyes going back and forth.
Hey. I did not mean to imply that you don't use those two pictures. What you do, this thing walks along, okay?
Oh, I see. And so you go.
You just, right. Okay?
Thanks.
It's from, you get the stereoscopic picture from different revolutions of the thing. Yep. Maybe he can.
Here, I'd like to leave one number with you. Some of this photography toward the end had a resolution in the ground of about 5 feet. You only saw the people lined up for Lenin's tomb because they were in a line. You
That's
couldn't
true.
see the individuals. Anyway, some of this photography, which was on about ASA2 black and white film, very high resolution film, very, very slow, would stand up to 40 times magnification. The negative was roughly 3 inches by 29 inches. If you blew that up 40 times and made a print, which no one in his right mind would have done, you would have had a print 10 feet high and 80 feet long, and it would have been sharp from corner to corner. The combination of this very slow film and a nice stable platform that isn't shaking with an airplane engine was just perfect. But that's a number to remember, and it shows why, in fact, the concepts that you talked about were possible.
Yeah.
Next, the last question from your classmate.
Hi, Hans.
Louis.
You mentioned that the Caspian Sea monster, and we couldn't produce some. Admittedly, we're a far more open society, and our mistakes sort of got known, and we didn't have to have people in satellites, but we had the nuclear airplane, and there was a facility in Wright-Patterson, and there were 2 large radars built up in North Dakota. And if it weren't open, the Russians would have won it also up until
Well, but Louis, we never built a nuclear-powered airplane. They did build the Caspian Sea monster.
a lot of money.
We did put a lot of money in it. General Donald Putt, remember him? He was a major general, and that was the argument for the nuclear-powered airplane. I remember vividly was like this: nuclear power is good. It was good for submarines. It must be good for airplanes. I mean, that was the whole justification that went into it.
Well, those who know Hans Mark know he could not give a talk without talking about nuclear or something, just as I can't be a chairman without asking about man in space. Hans Mark, when I skipping through his bio, I did not mention that Hans was Deputy Administrator of the National Aeronautics and Space Administration during the period when he was under his watch where they got the shuttle program launched, and the first of the beginning of the beginning of the beginning of the space station. The cover story that we were told, or the story we were told in the civilian sector, those of us involved with the space shuttle, was that the space shuttle would have been doomed because of overruns, were it not the fact that President Carter was convinced it was necessary for verification of SALT II. How does that fit in with the aerial reconnaissance, or the satellite reconnaissance you told us about?
Look, I was there precisely at the moment when that decision was made. In fact, I have a picture of the president in the cabinet room. Frank Press was sitting next to him on one side. Harold Brown was on the other. I was next to Frank. Bob Frosch was next to Harold. And the question was, look, every new administration that comes in wants to cancel something. You know, you have to show that the last guys were dumb, and so you need to cancel something. The issue was the shuttle or the B-1. Okay? And it fell to us to go in and persuade the president to keep the shuttle. And it was really a combination of reasons. One of the reasons, of course, was that the shuttle was in fact sized to carry the most capable reconnaissance satellites we had. But I think it went deeper than that. It was, I remember that Harold Brown can be exceedingly eloquent. And Harold was the guy in that meeting who carried the day for the space shuttle. Because he said, Mr. President, you know, you've heard all the national security requirements and so on, and I agree with them, and they're fine. But I also know you could do that some other way. You know, that there are other ways you could get those things into orbit. The real reason, Harold said, is that somehow it is in our destiny, in our genes, to put people in space and to go explore. And this vehicle is the first thing to do it. Now, you know, the B-1, he said, also he fought for the B-1 when he was Secretary of the Air Force. But he said, that's just not as important. And that was the way that that decision was made.
Okay. Let me thank you once again. Tell the audience that there is, so there are some refreshments in the back of the room, and I hope that Dr. Mark will stick around with us for a few minutes thereafter. A brief announcement. This lecture is part of the course Modern Space Science and Engineering, which will continue next week in its usual room at 3 o'clock, and the public is always welcome. And you really want to ask a last question? Oh, yes.
I could tell you I'm former Russian scientist, pretty deep involved in all this stuff. Now I have a full-time job for Museum of Science. And if you want, I could tell you a real story how Powers was shut down.
Yeah.
If you want.
Yeah.
Because I was
talk into the microphone.
This way, yeah?
There
Okay.
you go. Good.
Is it a shock?
Yeah.
It takes 3 minutes, no more. Because immediately after it was done, I was there. And it is very the piece of chalk. And it seemed about time to know how it was. It is Sverdlovsk. It is Sverdlovsk Airport. Approximately about 40 kilometers in Russian. Okay. Then it is ionospheric station, because I'm former ionospherist, and I was there. And it is abrasive plants up here. It is about 700 meters. And it is power
plant.
You know. And power was here, shut down. And how it happened? Shortly, no rocket shut down here. Rocket, targeted our plane. How it happened? Because when it was obvious that at first our firefighters, got a command to fire, not to get it, but it was unreachable. And nobody knows why, but it was commanded to return back. One did not. Maybe he wants to be a hero, maybe he didn't hear something. And the rocket, the missile, targeted him. And it is because power survived. It is obvious. And all the, you know, this is powers. This is our firefighter. This is rocket. And this is, you know, the sound wave. And this destroyed. I didn't want to tell it. It's the first time I tell this. I read a lot of articles about this. They never mentioned this. I know the video.
Spasibo.